Alright, so here we have another related rates problem. Let me just read it to make sure everything's clear. The volume of a right circular cone increases at a rate of 30 pi cubic centimeters per second. At the moment the height is 10 centimeters and the radius is 5 centimeters, the height increases at a rate of 5 centimeters per second. Find the rate of change of the radius at that moment. And I give you there the volume for a right circular cone, which is 1/3 pi r squared h. So, I'll break this down into the steps, which you wouldn't have to necessarily write out, but I mentioned that for step one, the first thing that you should do is identify the variables. Okay, well in this case it's pretty straightforward, I think. I've given you the equation that relates them already even too. So I mean the variables here are v, r, and h. The variables are things that change in the problem. So step two is to an equation to relate your variables. And again, that's given to you right there. So v is equal to 1/3 pi r squared h. Okay. Now, also very important, step 4, what is given? Okay. First sentence, it says the volume of a right circular cone increases. Right here, keyword increases at a rate of 30 pi cubic centimeters per second. So, it's telling us how fast the volume is changing, so it's telling us dv over dt. And that is equal to 30 pi cubic centimeters per second. It says it increases, so we know it's positive 30 pi. If it would have said it was decreasing, the rate would have been negative 30 pi, but it didn't say that. Also, it tells us that dh over dt is equal to 5, because it says here that the height increases at a rate of 5 centimeters. That happens specifically, so maybe I'll put little parentheses around here, specifically when h is equal to 10 and when r is equal to 5. Okay, so h is equal to 10 and r is equal to 5. And what do we want to find? Step 5. What do we want to find? It says find the rate of change of the radius, which would be dr over dt. Find dr over dt. And we want to find that specifically at this time when h is equal to 10 and r is equal to 5. So, those are my breakdown of the steps right there. I'm going to have to erase this right now for this problem because I need room to work this out. But we are going to use all of this in just a second. So if you're working this out, you might want to have it written down. So anyways, again, I do need to erase that so that I can have to work the problem out. So the first thing we're going to do, we're going to start with the equation that relates to the variables. We're going to take the derivative of that. Okay, so when I take the derivative of this, very important, I've got to use the product rule. Notice right here, I have r squared times h. So that is essential to use the product rule. So I'm going to think of it, okay, as one of my functions is like 1/3 pi r squared. The other function is h. So the product rule says, okay, take the derivative of this one, so it's going to be 2/3 pi r. Since I'm doing related rates, I have to multiply times dr over dt. The derivative of h would just be 1, but then times dh over dt, so that's just going to be dh over dt. So my derivative of volume here, which is dv over dt, is equal to, so it's going to be 1/3 pi r squared times dh over dt, because it's this function times the derivative of h. So it's going to be 1/3 pi r squared dh over dt plus, and then I have this function, or the derivative of this function times h, so this guy times this guy, so it's going to be 2/3 pi r, and I'm going to sneak the h right after that r, and then dr over dt. Okay, now I'm going to have to erase this as well here. So I just used that for the product rule, so I don't need that anymore. So at this point here, I basically have a bunch of given information that we just had erased a second ago. I was given that dv over dt is equal to 30 pi, so I'm going to plug that in for dv over dt. So I'll put that in right over here. So 30 pi, I'm putting this in where dv over dt was. Then I have equals 1/3 pi times r is equal to 5. At the moment that we're trying to figure out, what the rate of change of the radius is, r is equal to 5. So that's why I'm plugging 5 in for r. So 5 squared. dh over dt at that moment is equal to, what did we say? 5, okay, plus 2/3 pi, and then r is equal to 5, and h is equal to 10. And then dh over dt, this is supposed to say dh over dt right here. No, I'm sorry, I'm spacing out. Sorry. That's dr over dt. And then dr over dt is right here. And that's, our unknown. That's what we're looking to find. At this point, you guys, we plugged everything in, and now it's just a matter of solving for dr over dt. So we've got to get d over dt all by itself, okay? So, let me just work this out here. So it's 30 pi is equal to, if I simplify that right there, I'm just going to use my calculator. I've got 25 times 5 divided by 3, and that's 125 thirds. It doesn't simplify. 125 over 3 times pi, plus, when I simplify that, it's 50, 100 over 3. Okay. Alright, so I simplified this to 100 over 3. I've got dr over dt here still. So then I'd just subtract this over here. So 30 pi minus 125 over 3 pi. I'll just do the 30 minus 125 over 3. And end up getting, it's negative 35 over 3 pi is equal to 100 over 3 pi dr over dt. So now it's just a matter of dividing things. I notice, okay, the pi's are going to cancel out. The 3's would actually cancel out as well. And I'd just divide by 100, so I'd have just negative 35 over 100. So therefore, dr over dt will be equal to negative 0.35. And if I want to put units on that, this is dr of dt, so it's change in radius with respect to time. The radius would be measured in centimeters, time being measured in seconds. So centimeters per second. Now notice that that's negative, dr over dt is negative, which indicates that at that moment the radius is actually decreasing. Okay? So at the moment when the radius is 5 and the height is 10, the radius is decreasing. Yet the volume overall is increasing, probably because of the increase in height at that moment.